Right, this is going to be a slightly long video, but a model for an object with mass m is dropped from rest and can be expressed by the differential equation of m times dv by dt is equal to mg minus kt, where g is the acceleration due to gravity, v meters per second is the velocity after t seconds, and k is a positive constant. Solve the differential equation and show that v is equal to mg over k, 1 minus e to the minus kt over m. Given that m is 2 kilograms and for large values of t the velocity tends to 3.92 meters per second. Find the value of k and then find the value of t for which v is equal to 2.5 meters per second. Okay, so let's start with our differential equation. So we have to separate the variables. We need to take this to this side so it becomes m over mg minus kv is dv by dt, and then we'll just have to have a 1, otherwise we'll be able to get back to what we started with. We now integrate both sides with respect to t, so that actually means that we integrate this side with respect to v, so the integral of m over mg minus kv dv is equal to the integral of 1 dt. Right, where does this come from? Well, we think it might come from ln of mg minus kv. So if we differentiate that, so don't forget m and g are constant, so we're going to have minus k over mg minus kv. Okay, so we're going to get an extra minus k, and we need the m at the top. So just don't forget m is mass, so we're going to have the m outside, ln of our guess, and then we're going to have to divide it by minus k to compensate for that minus k there. When we integrate 1, we get t, and we have to add a constant. But we're told that when t is 0, it starts with rest, the velocity is 0, v is equal to 0. So we get m ln of mg minus k times 0 over minus k is equal to 0 plus c. So we get c is equal to, this is 0, so we're just going to get c is equal to m times ln of mg over minus k. Right, so if we now put that into this, we end up with this. M ln of mg minus kv over minus k is equal to t minus m ln of mg over k. Right, if we now take this to this side, and we have a common factor of m over k in both, we're going to have ln of mg minus ln of mg minus kv is equal to t. We can apply a rule of logarithms, but on this side, if we take the k up here and the m here, so we get kt over m. We're going to have that log to base a of x minus log to base a of y is log to base a of x over y. We get ln of mg over mg minus kv is equal to kt over m. Therefore, if we want to make this a subject, then log to the base a of b implies c. That means that b will be equal to a to the c. So if we want, we're going to have mg over mg minus kv will be equal to e to the kt over m. We now make v the subject, so we'll need to take this up here. So we've got mg will be mg e to the kt over m minus kv to the kt over m. Taking this over here, we're going to have kv e to the kt over m is equal to mg e to the kt over m minus mg. Just write that out again. Mg is a common factor, so we'll take that out, and then we'll divide by ke to the kt over m. And then we're going to have that v is mg over k, and then we're going to have, separating up this common denominator, we're going to have e to the ktm over e to the kt over m minus 1 over e to the kt over m. So that will give me mg over k, this will give me 1, And we write this as e to the minus kt over m as required by the question. So we know that m is 2 for part B, and as t goes to infinity, v will go to 3.92 meters per second, and we know that g is 9.8 meters per second squared. So as t goes to infinity, e to the kt over m will also go to infinity, which means that 1 over e to the kt over m will go to 0. So this function will just become this bit. So v will tend towards mg over k. So if we take our value of v, put our value of m and g in, we can find the value of k. So 3.92 will be 2 times 9.8 divided by k. Gives that k is 19.6 divided by 3.92, which gives that k is 5. So when we need to solve this equation for part C, so it's mg, so it's 19.6 over k, which is the 5, 1 minus e to the minus 5t over 2 will be equal to, we want to know where the time is 2.5, which is 5 over 2. Now it's a good idea to try to work with fractions here. So if we do, say, 1 minus e to the minus 5t over 2 will be equal to 125 over 196. When you multiply that by 5 and divide by 19.6 and divided by 2 and make it a fraction, that will give you e to the minus 5.5t over 2 will be 1 minus that will give you 71 over 196. So just use the fraction button on your calculator. Using the rule of logarithms, a to the c is b, c means log a of b. Therefore, minus 5t over 2 will be equal to ln of 71 over 196. Don't get worried here because this is actually negative, so the time will come out to be positive, and therefore t will be minus 2/5 of ln of 71 over 196. On our calculator, that will give 0.4061 or 0.406 seconds. Okay, this has been a video to show you how to solve a differential equation by separating the variables. I hope you have understood, and I thank you very much for watching.